Hello everyone, welcome back to STR8CHEM. In this video, we're going to look at the main chemical reactions in organic chemistry. But before we're going to do that, let's have a look at what does it mean by electrophile and nucleophile. These two terms are very important for you to understand before we would be able to talk about the four main reactions. So let's start with the electrophile. Electrophile means electron-loving. When you look at the word electrophile, you have the electro part and phile part. Electro represents the electrons, and phile over here comes from the word phileo, a Greek word, means loving. So an electrophile is an electron-loving species, and thus they are electron-deficient species. Examples of electrophiles are cations with H plus and O2 plus, Br plus, basically things that do not have electron-rich sites. They need electrons. Okay, so that's why the name electrophile. Lewis acids, AlCl3 and FeCl3, although they do not have a positive charge, but they do have empty orbitals, and therefore they will be able to accommodate electrons. On the other hand, nucleophile means nucleus-loving. Why? Because they are electron-rich species. They are the opposites of electrophile. Examples of nucleophiles are anions, species with negative charge, carbanions, and also molecules with lone pairs, such as water, ammonia, and alcohols. Now let's have a look at the four types of organic reactions. We have addition, substitution, elimination, and rearrangement. For the addition reactions, you have two types: electrophilic addition, nucleophilic addition, and for the substitution, we have three: electrophilic substitution, nucleophilic substitution, and free radical substitution. We're going to start by looking at the electrophilic addition. This is a very typical reaction for alkenes and alkynes. They are unsaturated hydrocarbons. What does it mean by unsaturated? It means they have multiple bonds. You have an example over here, alkene. This is unsaturated because you can still add atoms in here to have single bonds. So when you add bromine molecule in the presence of CH2Cl2, the solvent over here, then you're going to change the unsaturated alkenes into saturated. So when you have an alkene as a starting material, you will know that that will be electrophilic addition. So you're adding Br2 into the alkene structure to become the structure over here. Next, we're going to look at nucleophilic addition. This is typical reaction for carbonyls. Carbonyls with C double bond oxygen. So it's different from what we have looked just now for electrophilic addition, in which that reaction is typical for alkenes and alkynes. If you have C double bond oxygen, this is going to be nucleophilic addition. One example of nucleophilic addition is what you're looking at on your screen. We have an aldehyde over here reacting with KCN in the presence of acids. And as you can see, the carbon double bond oxygen has disappeared. So this is nucleophilic addition. Next, we're going to look at the elimination reaction. In the elimination reaction, it will involve the removal of small molecules to make saturated molecules into unsaturated molecules. So you can say that this is the opposites, okay, the opposites of what we have had looked in the electrophilic addition just now. One example is when you have your alcohols reacting with dehydrating agent, and from a structure without carbon-carbon double bond, when you have carbon-carbon double bond being made, you know that this is elimination reaction. In the free radical substitution, this is typically a reaction for alkanes converted into haloalkanes. You have alkane in here reacting with bromine molecule in the presence of UV, and you have substituted one of the H with Br. So this is free radical substitution. The other substitution reaction is electrophilic aromatic substitution. And this one is typical for benzene ring. So when you have benzene ring and you want to replace one of the H that it has in there with Br2 in this case, this is electrophilic aromatic substitution. You have substituted the H with Br. Nucleophilic substitution is a typical reaction for haloalkanes. The examples for nucleophilic substitution is when you have your haloalkane, CH3CH2Br, reacting with a strong base, and you're going to substituting Br with OH. This is nucleophilic substitution. For the last one we're going to look at in this video is rearrangement. This is when a reaction have rearranged. The last one we're going to look at for this video is rearrangement. Rearrangement is defined as the reaction in which atoms or groups of atoms in a molecule changes position. For example, like this. You have the same number of carbons, same number of hydrogens, same number of oxygen, and if you look here, you have the same number of carbon-carbon double bond. You have a double bond over there. Nothing is eliminated, nothing is added, nothing is substituted. What happened over here is the rearrangement of the atoms in the molecule.